Okay, welcome back again. So in the last example, we did a calculation finding net work as being the sum of all the works. So you could say, I'm trying to draw a sigma, I'm drawing an E. Net work equals work 1 plus work 2 plus maybe work 3 is negative. Okay, it should be a 3 right there. Let's fix that. And so forth. So we call that sigma work, or maybe W net. Okay, the sum of all the works. So this force times distance, this force times distance, this force times distance here, and then add them all up. But there is going to be an easier way to do it. If you can find the net force acting on an object, you can simply take that times the distance times a cosine of whatever direction the force is being applied with regard to the distance and get the net work as well. An example I used last time was an example of somebody pushing a box. Okay, so there's the ground, there's a box, the person's pushing it right here, and they're applying a force an applied force in that direction. All right, well, of course, there's friction, and friction is acting against right there. So kinetic friction. And the box is moving a distance, we call that a distance d. All right, so in the previous problem, we did force applied times distance times the cosine of the angle between them, which is 0. And then we did plus the kinetic friction force times this distance times the cosine of the angle which between them, which is 180 degrees, right? It's 180 degrees opposite from the direction of motion. And then we added them up. But why don't we just do the net force first? So in this case, the net force would be, let me change over to red right here. I'll write it above the net force since I took up all that space below. The force applied, right, minus what? Minus the kinetic friction force. Plus or minus whatever other forces are involved in the direction of motion here. But if the force applied is greater than the friction force, then that means it's still going to, the net force is going to be in that positive direction right there. We take that times the distance d times the cosine of the angle between them. If you add up all these forces and you figure out that, all right, well, the net force is in that direction, is in the positive direction, then that's going to be the direction that you compare to your direction, the direction of your displacement. All right, so let's just say I'll do green here. Sum these up, and so the net force is actually, we'll just say the net force isn't in that direction, okay? Well, you would compare that direction to the direction of the motion to get your angle phi right there. But it may just be simpler to sum up all your forces first, find out what they shake out to be, and then just multiply once by the distance d, and then your cosine of the angle phi, and get your net work that way. That certainly has its place too. And either this method or the other method you may find to be easier, but it is helpful to use them, be able to know how to use them both. So I'm going to finish this segment for right now. It's a little short one, and I'll let you take a look at example 8.4b, and we're going to be doing the exact same problem as before, but using this different method where you sum up all the forces first, then multiply it by the distance times the cosine of the angle phi. Okay, so look for that, and I'll see you back here when we continue after that example. Thanks.